In a different video, I did a walkthrough of the HuntTheWumpus game. In this video, I'm not only going to do a walkthrough, but I'm going to show you how the code makes some of the features work. I modified the game very slightly so that the game board is very small, so you can see both the game board and we can also see some of the actual basic code that makes the game work. We click on the splash screen and we get the game started. But before we do that, let me show you something. There is a state that is set up for the game. Right now we're in state splash screen because the splash screen is up. When I click the HuntTheWumpus game, it's going to switch to running mode and it'll get the game all set up. Here we are actually running the game. We have our room that we're currently in. You can tell the room we're in because the doors are set up. I can do a swipe gesture in order to move, and you can hear a bat. Let's start off actually by just showing how this little dot that shows up and then vanishes. Let's see how that works. The dot, which is from global dot, is a small circle on the screen. Let's go to where it's set up first. Global dot, here we go, right here. We create a variable called dot. We set our graphics fill to this very dark brown color, and there's a very dark brown somewhere. You might wonder, what the heck is this function that we're in even right now? This function is in init game. So every time a game initializes, we clear all the graphics. That's what the g.clear is. We do a bunch of stuff, and then we set up all the graphics that are going to happen. Now we have to set them up in a particular order. We're going to make the map first. That's all the different circles and things. We're going to create all the items, which is all the bats and the monsters. We're going to create all the doors, and we're going to create the warnings, which is the little things down at the bottom of the screen. Down here, like the little bat and stuff. And then we make our dot. And the dot, like I say, it's going to be dark brown. There's going to be a circle. We're going to position it at -40, which is way off the screen somewhere. And it's got a size of 10. You might think, well, all right, we set up the circle. How does it show up on the screen, and why does it vanish? It vanishes because we set up a timer ahead of time. With the very, very start, we set up a timer and say every so often, 50 milliseconds, we're going to run this timer command, which is this function right here. We're going to take the dot. Every graphics object, well, technically almost every graphics object, has the ability to examine and set the opacity. So we say, look, if the opacity is greater than 0, then just subtract off a little bit from it. And that sets the opacity down. That means that I click, the opacity is set to 1, but over a short period of time, it just sort of slowly vanishes. Let's see what else we got here. On moved, on pressed. The on pressed and on moved, let's scroll back to where I'd set up the timer. There's a couple other functions that get called back. On pressed, on moved, on released. Once we set these up, by the way, we then go into the basic forever statement. This is an extension that PC Basic has. Forever means I'm just going to sit here. I'm not going to say I'm not doing nothing, but I'm waiting for something to happen. I'm waiting for a timer to happen. I'm waiting for Bluetooth data to come in. I'm waiting for the user to click on the screen. The pressed and moved and released are all on a per graphics area basis. So you say G, which is I made my graphics. I made my graphics. I made my graphics. I made my graphics. Where did I make my? Here I made my graphics. I made my graphics in a certain spot, and it's 500 tall and 350 wide. And for that graphics, I'm going to on pressed, on moved, on released. When you clear graphics, by the way, it does not clear all these functions. So only set them up once. Don't keep setting them and resetting them. So the timer is what makes the dot go away. What makes the dot appear? Well, what makes the dot on moved? what makes the dot appear is the onPressed. The onPressed function will be called, and it'll be called with the original graphics object, and with an x value and a y value and whatever argument we'd passed in originally. We say global dot because it's a global variable with the dot, and onPressed opacity is 1, and we're going to set the center x to be x and y. Remember that most graphics objects have a x1 and x2 variables, and that sets the left and right edges of them, and a y1 and y2, and that's the top and the bottom. But you can also just set the center x, and that'll sort of jiggle it around to the right spot. What the heck is this gesture onPressed? Gesture onPressed is something from the gesture library. We go way up to the top somewhere here. Import function from game gestures. If we look in this package, there'll be a program, and I'm using air quotes there, called game gestures. And it has a couple functions built in, and the import functions from will import all those functions into our program. The game gestures functions, their job is we tell it stuff about what's happening with gestures, with the pressed and the released, and it then tells us stuff that we ought to do as a result. So on pressed, we just say, hey, by the way, game gestures library, I don't know how you work, but it got pressed right now. I don't know what you do. I don't know what algorithms you run, but I'm just letting you know. On move, and by the way, notice we set the opacity to 1. On move, because we can, as I'm going to click and then I'm going to drag, so I click and I drag, and you can see the little dot moving around. I click and I drag, and what happens is, when I move, I say, look, the opacity, if the dot opacity is more than 0.1, then set the x and y value, set the opacity. Cool. And notice I don't actually tell the game gestures about it. And then on released, I tell the game gesture library, oh, once again, it got released. And then what happens? Well, then what exactly happens depends on what state we're in. There's a state variable that says, are we running? Are we in the splash screen? The most common one is R for running and C for camera. Because remember, I can take a camera, I can click on the camera, and now we're in camera mode. We're not in running mode, we're now in camera mode. When I click on a dot, it'll tell me what's at that dot. Picture of the curling stone means it's an empty room. We click on a dot. So, what state are we in? Well, if we're in camera mode, we're going to, and now we got to pause. There's a map. There's a map of the whole dungeon. The map says where all the rooms are. And we're going to iterate through the whole map. That's what if we're in camera mode, which is just what we tried there, we're going to loop through all the items in the map. And remember, it's a global variable, and so we say global. We say, hey, what room is that map in? And that's just the index of it. The map is a two-dimensional array. So it's an array of rooms, and there's one for each room in the dungeon. So there'll be like 12 in this, like 3 by 1, 2, 3, 4 probably. So it's like a 3 by 4 dungeon right now, which means there's 12 entries in the map table. And we say, look, if we're going to loop down, each entry has one room, and it says stuff about the room. What could it possibly say? Well, let's take a look at the function that makes the map. And it's called makeMap. And that's where it's called, and it's used in some tests. And here's the function. Notice that I've documented what in the world the map consists of. The map consists of each room is an array. So it's an array of arrays. Each array has 8 elements in it. One is the room name, which is really just the index. So you say, hey map, get me room index 4, and then you say, well, what's the room name? And it'll say 4 right back at you. That can be useful for stuff. The second and third is the row and column, which is a 0-based number for, and it says, 0, 0 is top left. 4, 5, 6, 7 says, for this room, where does it go from here? So like for this room here, doink, doink. For this room here, there's a north, east, south, and west area which in the room is element number 4, 5, 6, and 7. Element 4 for this room, and this room is going to be 1, 2, 3, 4, 5, 6. This is going to be, by the way, room 6, as it turns out, for the one I'm currently in. In room 6, the room to the north, and therefore element number 4, is going to be room 1, 2, 3. This also lets us, when we're drawing the doors, figure out, like, should we draw a door or should we not draw a door? Like, there's no room to our right here, so we don't bother drawing a door. When I click on this door, by the way, it's going to move, and I'll show you that in a moment. Actually, I'll do that right now. Click, and we moved. And you click on the bottom one, and it goes back down. So we make a map, and we set it up. The map includes, like I said, where stuff is. And then the element number 8 is the actual circle that represents the room. I make all the rooms ahead of time and set the opacity to 0. Let me show you that. And when we make a map, we make it on a particular graphics area. For some reason, I always pass in the graphics. It's never a global. A lot of other stuff, like the map itself, that's a global. The number of rows and the number of columns, that's a global. For some reason, I always make I always pass in the graphics. It's somehow, it always feels better for it not to be a global. Map.clear, whatever the array used to be, we're going to clear it all out. Because remember, this is a dungeon game with levels in it. So we're going to go through level 1, and then we're going to go through level 2. When we go through level 2, of course, that's going to be a whole new map. Room index 0, we then go for each row and each column. We figure out what our room index is supposed to be. And then what is the east, north, south, and west by default. By default, the dungeon is completely filled in. And then later, if you played HuntTheWumpus, you'll know that not all the rooms get shown and not all the corridors are straight. We initialize everything with all the rooms and all the corridors. And then we go back and we edit the map to be something different. And so here we go and we figure out all the X and the positions. And here, right here, is where we figure out where it is we ought to display the circle. We make the circle, we set it to be room radius. And once again, the game is a game of levels. On a smaller screen, the circles are smaller, and a bigger screen, the circles are bigger. But in addition, the first level has fewer rooms in it, and so they're bigger because I can make them bigger. But as the game progresses, the rooms get smaller because I'm trying to cram more in, because it should be bigger because now you've gone deeper into the dungeon, you should be more experienced. Map.addRow, map is an array. AddRow will add an array to that map, and it will add a whole slew of things all at once. It's like a little convenience function. And we pass in the room index, which is 1, 2, 3, 4, 5. The row and column that it'll be in, and then our north, east, south, west, and then the circle. By the way, why in the world would room index ever be needed or not needed? And the answer is when I remove a room, the room index is set to like -1 or some non-valid value. That way I know it doesn't exist. So let's get back to the gestures, because that's where we were originally. So we're going to go to the whole top of the screen thing. So let's go way up. Hello. To the on released. It's always, I always call it on released unless there's a good reason to call it something else. So here we are. And we're in camera mode, because that's where we were last. For camera mode, we now go through the map. We find the room. We find the circle that the room represents. Which is the actual little room thing here. You might say to yourself, hey, but what if I make it not a circle? What if I make a dungeon where there's polygons or something? Well, I'm calling it circle, but it really just means it's some graphics object. For graphics objects, one of the neat features that's available in Best Calculator Basic is this intersect thing. If circle intersects the dot, that is, I have a dot object and I have a circle object. If they intersect, then I should take a picture of it. Let me show you how that works. I'm going to go into camera mode again. Now if I click, say in the middle of the quarter, that's not going to intersect, so it doesn't do anything. And I try it again, it doesn't do anything. And now I'm going to take a, say right at the corner, still doesn't, there. You'll notice they technically didn't intersect, but I still considered them to be intersecting. That's because it's a square and a square and sorry, that's a terrible explanation. I don't do a perfect intersection calculation, I do a rectangular calculation. So the circle is considered to be as if it were a rectangle, and the dot is considered to be as if it were a rectangle, and does it intersect at all? If there is one, then I call this take picture of, and then I switch back to my running state and I return. All right, so that's in case I'm in camera mode, and then there's some end mode and stuff like that. If I'm in E, which is end game mode, then I've displayed stuff and now I'm switching to running the game and I gotta do stuff. Or if I'm overall in F mode, which is finish mode, and I've showed you the final score, well, then I need to pull down whatever the screen was and I need to initialize the game streak. That's the whole like series of levels, and I need to initialize my game because I'm gonna actually start playing the game again. S means I had been in the splash screen, and if you click on the splash screen, what should happen? Well, you initialize the game streak, which is all the levels in the cave, and initializing one game within the streak. You initialize the streak first, and then one game within the streak. And now here we are in R, which is we're running. What should happen? See this gesture result? That comes from that gesture library. And we say, hey, what was the gesture result? Well, the gesture result was up, then, let's actually show the code. Then we grab the next room index is going to be whatever the north one was. And if it's the gesture result is right, then the next room index is whatever to the right was. Remember 4, 5, 6, 7? That's the north, south, east, and west. And if there's no gesture result, then we're going to say, maybe it's a door. Each room has up to 4 doors. I actually only ever make 4 doors. And then I either display them or I don't display them. So I say, hey, did the dot intersect a door? If so, perhaps I should go where that said. When I set up a door for a particular room, I say, by the way, the door data, graphics objects always have a little data object associated with them, so you can save and then get back information about each object. That's the room index to go to. And then down here I say, oh, is there a room index? Well, go to it. And then you say, well, how many doors? Well, okay, end doors. At the end of the game, it tells you how awesome you were based on how many doors you went through, and then it actually does some calculations, and it's a per level thing, because if you're on a smaller level, then you're allowed to go through fewer doors, but if you're on a big level, you're allowed to go through more doors. And then this is global camera. Global camera is that little camera element there, and I just clicked on it, so now I'm in camera mode, which you can't really tell, but I am in camera mode. And I'm going to take another picture. I'm going to say maybe the dragon is there. There. Nope. Turns out that's empty too. All right, let's see what else we got in this game. Now remember, there's a bat somewhere. Let's see if we can. Now we just heard the dragon. How the heck did that dragon sound get made? Well, let's once again scroll up to the top. Let's take a look at more what stuff we've imported. Import functions from game gestures. Import function from music for games. Let's take a look at those. Music for games. We'll edit that. Now the import functions from means I'm going to grab this program and I'm going to import all the functions. But it can also be a little program. And what I usually do is that any program is either a library and it's primarily used to grab all the functions in it, or it's a real program that you'd want to run. But for every library, I always have it do something when you actually run it. That way, when you run it, it looks like it's something fun. In this case, the music for games, if you run it as a program and not just import all its functions, it gives you a little menu and says, do you want to listen to some of these things that I've got? And there they all are, and they're listed. So here's some of the functions. There's death and there's space. I use the same set of functions for all my games. So the space here, that's for like one of the space games. And Triumph is a do-do-do-do. And there's a warning, and hey, there's a funeral march. Now, but we just heard the dragon, the monster. So there's a bat, pit, monster. Here we go. Monster. Here we go. The monster function. When I know that there's a monster in a nearby room, I will call this function, and it will do whatever it is supposed to do stuff about the monster. In this case, it's going to play some music. Let's take a look at it. It's going to do this I-120. First of all, what the heck is this function? This is the play function. It plays music. Music? What kind of music? And the answer is there's a thing called a music macro language. I didn't make this up. It's been available for microcomputers for ages. What I've done, and in the music macro language, things like D means do the note D, da, or ABC, da da da, whatever it is. But there's some special things. O1 means switch to octave number 1. Da. L1 means the length of the note. This is going to be a whole note, which is longer note because it should be longer. But what the heck is this I-120? What in the world did I-120 do? And the answer is I stands for instruments. This is a thing I've done with my version of the music macro language because BC BASIC has access to a whole MIDI chip system that Microsoft has embedded into all the C# programs. So from any C# program, you can access this cool little MIDI set of sound effects. And instrument number 120, and this is a MIDI thing, is reverse cymbal. And by playing a very low reverse cymbal note, you can hear the monster. Let's hear it again, and you can hear what it sounds like. It's just a slow, low cymbal sound. I mean, normally cymbals are high, ting, ting, ting. But if you set it to low, you get that kind of breathy, monstery sound. When we go up, by the way, we hear the bat. The bat is actually kind of cool. The bat is instrument 124, which is a bird tweet. And you might think, that is the weirdest bird tweet I've ever heard. And the reason is that it's on kind of a slow tempo. T100 means a slow tempo. L1 is it's a whole note, so it's going to be kind of long. This up, up, up means we're going to be in the 3rd octave. By the way, when you do a play, it starts off, and you're not playing anything, it starts off with a standard octave. If you play again, and the last thing that was playing has completely finished, that's a new thing, and that octave is set to the original. If you play, and then you play, and then you play, and the new plays happen before the first play has finished, then it will keep the old octaves setting. So the up, up, up would keep going up, up, up. So the bat has this weird sort of bird sound to it, which you might think that doesn't sound like a bird to me, but it is indeed a bird sound. Let's hear if we can hear a pit. There it is. That's the pit sound. The pit is instrument 123, which is a C-shore. And it's a lower octave and a D note. And that turns out to be a kind of a cool, I can hear like a cave thing moving in and out. And hey, you know what? Let's actually just run into the monster so we can hear what the death by monster sounds like. That would be Chopin's Funeral March. For longer things that are actual music that I have to transcribe, I'll do it bar by bar, so I'll usually just simply set up 1 bar, 2 bar, 3 bar, 4 bar, and then bang them all together. And then throw in an instrument and a tempo, which are separate because you often want to fiddle around with them some. This is instrument number 21. Instrument 21 is a reed organ. There's a couple different organs built into the MIDI thing. Hey, while we're at it, see that curved? We had been in state E, end game. When you click on the end game, it pops the end game down, removes the old things, and finishes off. So you can't see that curved chord anymore. There's a whole system that I've got in place for removing old rooms and then wiring them back in and then drawing the quarter. Drawing the quarters was remarkably difficult. universal. Here we go. So the way, whenever I say, hey, I need to display a corridor, I'll, from one room to another room, like, all right, I find the room that I'm starting with, the index 1, and the x and y value is, every room has an x and y value, and I have these functions, room x and room y, that given a room, it will tell you where it's supposed to go. The room in this case, sometimes I deal with rooms by indexes, room 1, room 2, room 3, and sometimes I deal with rooms as arrays. I always try to be consistent. If it's called a room, that's the whole array with all the data. If it says index, it's the index to the room. So I pull out the x and y, and then I'm going to say, well, what's the corridor width? How wide? A corridor consists of 2 lines, one on the left, one on the right. How wide should that be? Well, I set that up somewhere actually in the init game, and it's based on like how big your screen is and how big the rooms are, and to make it kind of look good. And so that way, it's in one spot says how wide it should be, and then I fiddle with it from there. If the y value, and then, well, actually in this case the x value, if the x value of the 2 rooms, like these 2 rooms, if the x value of the 2 rooms is the same, then I'm going to draw a north-south corridor. If the y values are the same, the up and down, so like this room and that room, the y value is the same, I'm going to draw a little north-south corridor from x1, x1 to 10. But if they're different, then I'm going to have to figure out, like, well, which port am I running to? The port's 4, 5, 6, 7. Which port do I go from here to there, and which port on there? And then I'm going to draw a universal corridor from this point and the port north, south, east, west to the other one north, south, east, west. And then it just gets complicated because there's multiple universal curves. Am I doing an east-west to a north-south? Am I going north-south to east-west? Is it all east-east or is it north-north? So there's different kind of curves depending on how it should be done. What I did to do these, by the way, is it's so complicated to get it right that I did it in a little test program first and drew these functions in a little test program where I could exactly control all the variables that I wanted to and the curvatures and everything like that. And then when I was happy with them, I just blumped them all into this one. You might ask, why didn't I make them in a function library? And the answer is, music is something that all games have. So it makes sense to be a library. And gestures is something that a lot of games are going to want. So it makes sense to be in a library. But how to draw a corridor for HuntTheWumpus is something that only HuntTheWumpus is going to need. So I kept it in HuntTheWumpus only. And look at all this complicated math. In order to figure out what should the radius be, what's the curve radius, how do we handle the connectors, how do we. This took a while to come up with, like, how do I draw the arcs and all that. One of the fun things about Best Calculator Basic, by the way, is because it's a modern version of Basic and a modern sort of reimagining, I can do things like, when I want the square root of something, I have a little square root symbol. And when I want to square things, I can just say squared and be done with it. While we're on that topic, let's go back to the top. I want to show one other cool feature in Best Calculator. And then I'm going to finish this because this video has been going on for 30 minutes. The other advantage of being a modern version of BASIC with the modern facilities that new computers have is A, I can have tons and tons of colors. Where do I get these colors from, by the way? And the answer is, I think these colors came from, I went to the hardware store and got some paint chips, and I scanned them in. Actually, I think I took a picture of them. I took a picture of them with my phone, and then I used paint, and I used a little eyedropper and said, what color is this nice color of brown that I want to use? And that's the color I used. If you're like me and you're not very good with colors, the paint chips from the hardware store will get you a set of coordinated, good-looking, modern-looking colors. However, let's talk about the other value to having a modern version of BASIC. In addition to having all those MIDI things available, which the old microcomputers didn't have. Like if you had an Apple II, it would go bloop, 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 bloop. Or it would have some really complicated sound synthesis chip that was hard to control. But with mine, I say, make it sound like a piano, and it sounds like a piano. I'd rather it sounded like a reed organ, and that sounded like a reed organ. Let me make some birds, and it's birds. But the other cool thing in modern computers is they have these really nice fonts that have all these Unicode symbols. So where's the bat from? It's from the bat Unicode symbol. The monster is from a dragon Unicode character. The pit is from the pit Unicode character. I wanted a camera. Actually, technically I wanted a drone, but I couldn't find. This was the best Unicode picture of a drone I could find, because I couldn't find like just a drone or a lightweight plane or a model plane or anything like that. So I just decided to call it a camera. All right, so at this point, you can see some of the fun things that you can do in Best Calculator Basic. You can see how I do some of the effects that HuntTheWumpus has. You've seen how I can use some of the programming concepts like function libraries and state and global variables and callbacks in order to implement some of the features. You've seen how Best Calculator Basic includes some advanced features like the ability of graphics objects. You can set their center X and center Y. That's super valuable, super useful. You'd think more things would be able to set the center of things. I don't know why they don't, but I wish they did, because I almost always want to center things. And the intersection, the whole concept that you can take two graphics objects, see if they intersect. Every game needs to check intersection. This makes it easy. And you've seen how I use a state variable in order to control what I should be displaying on the screen at any given time and what should happen when the user clicks on the screen. When I'm in splash screen mode, if you click on the screen, that means I need to start a game. If you're playing a game and I click on the screen, that means I need to see if I've clicked on a door or done a gesture. If I'm in the end game, it means I need to switch to starting the next game or to switch to the final finish page. All these things are things that as you program games, you'll learn how to do. You've also seen how I can modify the code so that it handles different screen sizes. This is actually really important. I like to actually play this game on my phone. I have a Windows phone because I'm one of the 3 people left in America that has a Windows phone. But I play it on my Windows phone. It's kind of fun. I can play it on bigger screen. I can play it on a smaller screen. We have these enormous giant screens at work, and I can play it on the enormous giant screens as well, which is really fun. You saw how I could create a data structure, this map data structure, in this common, consistent way in order to get the information I need about each room and have just one little hunk of data that says what my map looks like. The functions needed to decide, like, should I go left, should I go right, should I whatever, they don't care what that data is. They just apply it consistently. What that means is that I could start off by just making a dungeon that was literally always a grid of rooms. And then later on, I can update it to remove rooms and make curved corridors. I love the game gestures, by the way, and I love having these curved rooms. It really does make an enormous difference in the playability of the game. And lastly, I'm gonna leave with how did I make the choices I made about HuntTheWumpus? Why did I modify the game from the original? And the modifications I made was, firstly, so that there'd be levels. The original HuntTheWumpus, like you start it and it says, do you want a small game, a medium, or a big game? Or whatever. There's actually a bazillion variations of it. Small, medium, or big. And it's like, well, but the way people play games now is you want to go through levels and level up. Secondly, I removed the killing aspect of it because in these more modern times, we tend not to just say, let me go into a cave and kill everything in sight. Because, well, actually, and I'm thinking, well, that's not how Doom works. That's not how GTA works either. That's not how Halo works. However, This makes it a game that does not have violence in it. You just send off a drone. It means you can use your drone in a more interesting way, I think, to take pictures of the monster, and then you can also use it to find out what's going on in the dungeon and help solve your logic puzzles. And I want to finish off with one more part of game design, which is one of the last things I did was to try to make sure the game was fun. And that means modifying the progression through the levels. I tried a couple of different schemes to progress through the levels before I came up with the one I liked the best. How many camera shots should we be able to take? How many levels should you have? 5 seems like about the right number. I tried some more and I tried some less, and 5 seemed to work the best for me. I fiddled around with how big should the dungeon be. Well, and now clearly I should either talk or play the game. How big should the layers be? How easy is it to manipulate and modify things until it's easy to play, until it's fun to play? That's actually one of the most important aspects of making any games. When you're writing a game and you think, I want to spend X number of days on this, the last couple of days should all be adding fun. Right? You're not adding features, you're tweaking the features to make it more fun to play. And I hope that you find it fun to play too. I hope you've enjoyed listening to me ramble on for over 30 minutes about how the BASIC here works, but I do hope it's been enjoyable for you. And I hope you get a bigger appreciation for the work it takes to make a game, both how easy it is and how it can be more difficult and more challenging. Thank you.